this one. Still no problem. We have a time, but I'll do it. Okay. Next, we discussed about a OSI layer, and we discussed about application layer and presentation layer and session layer. Okay, application layer deal with the application part in the networking, like a client side application, server side application. Example, web browser, Outlook. These are all client side applications. Example for application layer. And of course, we use a protocols when you are communicating. So that is also taken care by your application layer. Presentation layer, encoding, decoding. Whatever the data format, it will convert into ASCII format. So compression and decompression. It compresses the data while you are sending a data, we are compressing data. Encrypting the data. So while you are you are using HTTPS, it using encrypting. So then no other can able to see your data. It's end-to-end encryption type. Session layers. So create a session, maintain the session, and terminate the session. Session layer use when you are sending a request, session ID will be created. Okay, and session will be terminated once you received a response from the server. Okay, when you're sending a request, session is created, and when you received a response, then session will be terminated. Until the time it will maintain the session. Okay. The next, now we are seeing what is a transport layer. Guys, remember, whatever the data it is, whatever the layer it is, each layer will do certain things to your data. So like the part of that. But what each layer, whatever the type, whatever the kind of data it is, we call the data as a PDU. What is PDU? Packet data unit. Packet data unit. So whatever the layer in the OSI, the data name is PDU. Packet data unit. Okay. So what is the transport layer? Provide end-to-end connectivity. It do error correction. Transport layer segment the data, means it cut the data into small pieces. Why cutting data into small pieces? You are sending a big data, means you have sending a block of data like this, bigger in the size. But while it is a destination reaches, data is reached, but there is a small problem is there, very small data is corrupted. Small corruption is occurred. And again you have to send it again. Again destination received. And there is some other place, there is some data problem. Again you have to send. So for one sending one packet you have to send 10 times. It means lot of burden on both server and a client also. Lot of burden on server and client. So instead of that one, I cut the pieces, data into small pieces. I send a piece by piece. I'll send a piece by piece. And each piece has a numbering on it. Okay, a sequencing numbering on it. So it is very easy to assemble back at a destination. We send a packet. We divide the data into small parts and we assemble at a destination. Okay, so then this is called a numbering and sequencing. So what is this error correction? How it is error correction? You can see this example. I have a data is called a hello, how are you? What is hello, how are you? You can see this is hello, how are you? I divide into parts 1, 2, 3, 4 and I send. All packets are received except the third packet. Okay, so it is hello, how are you? Totally 4 packets. Okay, so each one like 1, 2, 3, 1 by 4, 2 by 4. We send first hello. Yes. Okay. So first destination received a hello. It sent an acknowledgement. I received a 1/4. This acknowledgement for a 1/4. Just for understand. Next, you receive you send a how. Then how is received. Then it send an acknowledgement. You send R. It not received. You send U. U is received. Okay. You send how is received. So how acknowledgement is there. You send a hello. Hello. Hello is received like that. So you will receive a part. Okay. One second. Oh. So it is. You send it and hello received. It send an acknowledgement. So you send a how. It is saying hello is received. You send R. Third one. You send a third one. R. It is not sending any acknowledgement. No acknowledgement. And you send U. It is received. So what is the missing packet here? So 1/4, 2/4, 3/4, 4/4. Now we have 1/4. So hello, how you received. Then source understand this part is missing. 3/4 is missing. So then I will send again. Then R is received and I receive an acknowledgement. Okay. Now if you are assembled like this, hello, how you are. Missing, right? So then the sequencing number is there. Based on this numbering, again they will arrange it. I'll give you a simple idea. You and your friend, or maybe 3-4 members, went to take a Xerox. Maybe in your college days, you went to the Xerox shops, right? For material printing. It's a one book, 3-4 steps, right? So you're like whatever it is, like you are giving a something like a 20 pages or 50 pages, something like, okay. What you will see, you check that page and the page numbers. How you know which page is missing? So you check the page number, particular page number is missing. So they'll ask, so this page number is missing. So please copy again and we can insert into that one. For example, 14th page is missed. So you see 1, 2, 3, 4, 5, 13 is there, 15 is there, 14 is not showing. Something 14 is having problem, right? Then you will ask the Xerox guy, so where is the 14? So take the copy of 14 and then you can insert it. So this is the kind of explanation it is. What is missing, we'll put it and arrange it in order again. Okay, so this is called a error correction kind of stuff. Okay, yes, understand this one? Numbering, sequencing, error correction. Okay.
Yes, sir.
Very good. Multiplexing and demultiplexing of protocols into TCP UDP. In our OSI, when you are what happened at transport layer, there is a TCP blog is there. So like a box. Think like it is a box. Another one is a UDP box. Two boxes are there. What is the use of this box? I will tell. So there is a TCP type protocols and UDP type protocols. So is it there? Yes. So these are TCP type protocols. HTTP, SMTP, FTP, all these are like SNMP. Okay, these are all so many are there. So there is are all TCP type protocols. TCP type protocol. The protocol behavior. Based on that, we will say it is a TCP type protocol. UDP. UDP type protocol. So UDP type protocols. Okay. So normally we learn from top to bottom. That's why some people will get confused in this one. So, but here it is. I'm telling in simple way. Look at this part. So there we have seen lot of protocols here. These protocols either TCP or UDP or both is also there. TCP type protocol is there, UDP type protocol is there, or both is also there. If you want, you can say like a protocol. Number list. It is FTP, TCP, SSH, TCP and UDP. Telnet is again TCP. SMTP is TCP. You want to check? Totally 40 port numbers. Okay. TCP, UDP. So it is some protocols TCP only, some are TCP and UDP, some are UDP only type. So it is trivial file transfer protocol, UDP protocol. HTTP, DHCP, UDP, okay, POP3, NNTP 110, 119, sorry, 119. NTP is UDP protocol, okay. NTP is a UDP protocol. Okay, so SNMP, TCP and UDP protocol. Okay, LDAP, TCP, UDP, HTTPS, TCP. Okay, this is something TCP, RTP. HTTPS is a TCP. IMAP TCP. Okay, this is 3389 TCP. Something it is UDP protocol. See it is. So there is a TCP type protocols UDP. So I given this is nonsense. Here it is certain list of protocols. In this list of protocols, some protocols are TCP type protocol, UDP type protocol. Only that's it. Okay. So remaining is, so if a protocol is TCP type protocol, then the behavior is, it is a acknowledgement based protocol. Acknowledgement based protocol. Okay. See TCP type protocol. If protocol is TCP type of protocol. Acknowledgement base, it means this is the source and here is a destination. I send a packet, destination received. Destination will give you an acknowledgement. I received a packet. Means you know you're sending a packet and you receive a packet. You knowing that you send a packet, it received a packet. You send a packet, destination received a packet. So source knows destination, at destination packet is received. You send a packet, destination not giving you an acknowledgement. No acknowledgement from the destination. So what do you think? This packet is not received by destination. So what we will do it, we'll send it again. Once it is received, it will give you an acknowledgement. Again, I will repeat, guys. Listen carefully. Source and a destination. Source means who is sending, that is source, who is receiving, that is destination, right? Source send a packet, destination received a packet, and destination send a acknowledgement. Then source knows destination received a packet. Source knows destination received a packet. Source send a packet, destination does not give any acknowledgement. So source understand that destination does not receive the packet. Source will send the packet again. Once destination received a packet, it gives the acknowledgement to the source. Then it is say like yes, destination received a packet. So in a TCP type of protocols, acknowledgement protocol, of course, there is a story of TCP, but we are not telling that TCP total story, sync, acknowledgement kind of stuff. It is very simple to get for ourselves. Is easy part we'll choose is it is acknowledgement based. Okay, so we understand destination is received a packet or not. If destination not send a acknowledgement for the particular packet, then what you will do, will send it again. We can send it again. That's why TCP type protocols are reliable protocols and connection oriented. Guys, again, connection oriented and connectionless not belongs to wired or wireless. Okay, nothing is Wi-Fi, nothing is wire. Some people wantedly telling that kind of example without knowing it, without make suring correctly. Okay, even that is become one question in interview last one place. Okay, so again I'm telling guys, connection oriented, connectionless, nothing to do with your media of connection, like it's a cable connection, Wi-Fi connection and all, nothing to do with it. Connection oriented means I'm talking, you are listening, I want to know you're listened or not, right? So TCP type protocol, send a packet, destination received, and destination is telling I am received through using acknowledgement. So source knows destination is received. That's the connection it is maintaining throughout the communication, toward the packet delivery, toward the communication. TCP type protocols maintain the connection with the destination. Okay, sending and receiving acknowledgement. User datagram protocol, no acknowledgement. It's not based on the acknowledgement. Source sent a packet, destination received a packet. Source sent a packet, destination received a packet, but source don't know destination is received or not. Source don't know destination is received or not. Okay, source don't know it. For example, you send a packet, destination received, you don't know. You send a packet, destination, this is UDP type. You send a packet, destination received. Send a packet, destination received a packet. Good. You send a packet, destination packet is received. But you don't know whether it is received or not. You send a packet, destination is not received, but still you don't know. Then you will continue sending. Even you don't know the destination received a packet or not. Just you will send. We don't know whether destination received a packet or not. So this is the UDP type protocol. No acknowledgement. Oh, not reliable. We don't know destination received or not. Connectionless. We don't maintain any connection. Not a continuous. There is a packet and give it. That's it. We are not maintaining any connection. So guys, this is a TCP type and UDP type protocols. So understand there is a lot of protocols. Some protocols are TCP type protocols. Some protocols are UDP type protocol. Some are both. Some are both. Some are TCP and UDP both. Okay. maybe it is based on the establishment of connection. Okay. How it is works and all, that is separate one. Okay. So TCP type protocol are acknowledgement based protocols. In communication, we use both type, TCP type and UDP type, different type of protocols we use it while you are communicating one to another one. So all TCP type protocols we put it in a TCP box, and all UDP protocols we put it in a UDP box. That is called a multiplexing, demultiplexing of TCP UDP protocols into TCP UDP. And transport layer also do flow control windowing. What is this flow control, guys? I have a two PCs. For example, this is 1 Gbps connection, and this is 100 Mbps connection. Okay, so it can give data very fast. It can receive data very slow. Right? I'm giving a 1 Gbps, like I given lot of packets at a time. A destination cannot receive all the packets. So how to match it? First, estimate how many packets can able to receive by destination, like a 10 packets at a time or 20 packets at a time. So you estimate the number of packets can received by destination. Based on that, you have to send it. Otherwise, what happen? For example, destination can receive it only 10 packets, but I am sending 20 packets. So destination receive 10 packets, it drop the 10 packets. Again you have to send. Again you have to send. Okay. So that is called a flow control or windowing. Source estimate the destination receiving packet capacity at a time. Again, already I told guys, PDU, packet data unit. It is a data in the any layer. It is a PDU only. TCP header. What is a TCP header? TCP header contains the segmenting data, numbering, sequencing, the TCP IP protocol, sorry, TCP and UDP protocols information. Entire thing is stored in the TCP header of this packet. Okay, TCP header is added to your actual data. So like actual data, PDU, then this is called a segment. The transport layer, after transport layer means what are the things happen in the transport layer? The outcome of transport layer is segment. Of course, that is also a PDU. Okay, so from transport layer we are getting segment sent to the network layer. Guys, understand transport layer and TCP UDP?
Yes, sir.
Very good. Someone know already, guys, so don't worry about them. So they know already. Some are new. Please, if you don't get it or you want to see once more and you ask me later also, no problem. Okay, any choice you choose. Okay, better to know better. At least few points you have to tell about it. Network layer. So the network layer means the segment is sent to the network layer. Network layer dealing with routed protocols and routing protocols. First of all, I will discuss about routing protocols. Routing means you want to reach the destination, right? Like google.com, facebook.com, right? I want to reach the destination, some destination, but I don't know the how to go to it. And so a lot of router switches in between my laptop to the google.com server or a facebook.com server. Then I need a path. For example, I want to go to railway station, or I want to go to Delhi, I want to go to Noida, I want to go to Chennai. Which path, which direction, right? That is there. What we will do, we will put a Google Maps to reach the destination. Which is the best and simple way to reach the destination is we'll choose from the Google Map. Almost like that only. These routing protocols to reach the certain destination. So how to reach the destination will be given by routing protocols. like a RIP, EIGRP, OSPF, BGP, ISIS. Routed protocols. Every device must have a IP address to communicate in the network. First standard rule is every device must have an NIC. If there is a wired or wireless, every device must have an NIC to communicate in the network. Next, how to communicate? We need to address one to another one, right? For example, I want to talk to some person. Okay, some person means I need to know their name, phone number, kind of stuff, right? So how to address them? Like, you know, you don't know a person, then how you address them? Like a hello, right? Hello, how are you? How, sir, madam, kind of stuff, right? Generally, in a formal says. You know the person name, like you will call with a name, like hello Kajal or hello Abhinav or like that. We put a name addressing. So that is a routed protocol. So the second rule is then first is NIC, second one is must have an IP address to communicate in the network. How to communicate? We use the protocols, of course. So this is what is IP address. In IP address, we have a two type of IP addresses. Routed protocols. Point is routed protocols means IP address, SPX, IPX. Same story is there, but I am not going to tell. I am telling about IP address only. There is IPv4 version, IPv6 version. Routed protocols, routing protocols. So here it is. What happened? We got a segment from the transport layer. So to the segment, we are adding our source IP address, means my PC IP address and destination where you want to reach that destination IP address. Source IP, destination IP will be added to your segment. Then it is called as a packet. Then it is called as a packet. So what is the packet? It is a source IP and destination IP will be added to your PDU. That is nothing but your segment. So that is called a packet. So the packet is coming from network layer. Okay. Segment is sent to network layer and network layer send a packet to the data link layer. Okay. Next. In the data link layer, actually two layers are there. One is LLC, another is a MAC layer. Okay. So what is this LLC and MAC layer? MAC layer belongs to LAN, LLC, that is a WAN protocols. Okay, kind of stuff. So LLC, logical link control, it's a WAN protocols dealing with the WAN protocols like a PPP, point to point protocol, SDLC, frame relay, MPLS, and some other WAN protocols. Okay, it is a data link layer. Okay, when you are communicating from one system to another system, if you use a WAN protocol, you are communicating over the WAN protocol, means that is a WAN link. Even it is a small size or big size. WAN link is simply you are communicating using WAN protocol. One network to another network, when you are communicating, use a WAN protocol means it's a WAN communication. You not use the WAN protocol, it is simply a simple connections and all. So it's not a WAN, it is LAN only. Next is a MAC layer. So data link layer, LLC, logical link control. Next one is MAC. Media access control. You know already what is MAC address. MAC address is a hardware or a physical address. MAC address is a hardware address or a physical address. Data, okay, so this data link layer, in a data link layer, we add a MAC address to our packet plus CRC. So what is the thing we'll add? Source MAC address means my PC MAC address and destination MAC address to the packet and CRC, cyclic redundancy check. So total combination we call it as a frame. What is this CRC? CRC Cyclic redundancy check, it is used for a error checking. What is error checking? When you transfer the data to the destination, at a destination, the CRC value, with using a CRC value, the CRC algorithm will verify with the CRC value. So with CRC algorithm verify your data. Is data is as good as while it is sending, or it is corrupted while traveling from there to here. Okay, so it is do error checking. If data is corrupted, it drop the packet and don't send any acknowledgement. So source has to send the packet again. Okay. Source MAC address, destination MAC address pack. You'll add it to your packet plus CRC. Cyclic redundancy check. So this is total, we call it combinedly, we call it as a frame. The frame will send to the physical layer. Okay. Now last one is a physical layer. Frame is converted into bit stream. Bit stream means 0101 kind of binary bit stream it is. The frame is converted into bit stream. Bit stream again converts into electrical signal or a radio signal or a light wave signal. Depends upon what type of connecting media you are using. Are you used Ethernet type like a wiring kind of stuff or a coaxial kind of stuff? That is electrical signal. You are using a Wi-Fi kind of stuff to communicate, then it is a radio signal. You use a fiber channel kind of communication, then it is a light wave signal. Okay, so this is your OSI layer. Guys, when you are communicating from one PC to another PC or one device to another device, the communication goes from top to bottom and bottom to top. Look at here. First, it is starts with a application layer, then presentation layer, session layer, transport layer, network layer, and data link layer and physical layer. Then physical layer send a signal to the destination either in electrical form or wireless form or whatever it is. So finally it is received at a destination. But physical to physical, what is the connection between two computers in a network is physical connection only with wire or wireless connection. Physical connection. So the physical layer in the destination, so check the electrical signal, convert it to bit stream. Bit stream will be converted into frame. Frame sent to the data link layer. In the data link layer, so frame will be checked with the CRC whether any data is corrupted or not. In a data link layer, so frame is checked, no errors, then it check the source MAC address and destination MAC address. Okay, so source MAC address is the PCA MAC address. For example, first one is PCA, second one is PCB. So PCA's MAC address, and it store a PCA MAC address in one side, and check the PCB MAC address and check for the verification. Then it is good. Then it is go for a network. In a network layer, so network layer received a packet from the data link layer, because data link layer having a frame, the frame is divided into mainly first and last part is to the packet is source MAC address, destination MAC address, and last one is CRC. CRC duty completed, so it is verified your data, no errors and all, and source MAC address, destination MAC address verified. Then what is the leftover packet? The packet will be go to network layer and it check the source IP means PCA IP address, source IP, and destination IP means PCB IP address. Now, if the IP address matches with the PCB, then it will accept. Okay. So then the network layer verified the source and destination IP, and the system what it will do, in the network layer we have a source IP, and in data link layer we have a source MAC address. It means PCA IP address and CPM MAC address received at a PCB, and PCB create a record called ARP record, address resolution protocol. So that is called, it maps the IP to MAC address, ARP. Okay, so what sir it is? You got a segment out of your network layer. The segment will be sent to transport layer. Then it will try to put it in a numbering and sequencing and all other kind of stuff. Okay. And of course, the session ID will be received from the PCA and it is note down that PCA, that session layer, and when it is transferring, it use same session ID. In a presentation layer, it is a reverse order. The encrypted data will be decrypted. Encrypted data will be decrypted. Compressed data is decompressed. And converted data means encoding data become like a decode the data in presentation. And finally it will give it to your application. It verify this protocol same and it will be going to give a reply for according to your PCA request. Again, the PCB become a source. So obviously when it is sending application layer, presentation layer from PCB, when it is replying application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. In PCA, sorry, it is a destination now, right? So physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. So it's a up and down and up is there. So this is an explanation of ping command, guys, and some network related commands. This is the comparison between OSI and TCP model. Guys, TCP IP is also called as DoD model, which is came name is earlier. Then it is changed to TCP IP. And when you are comparing, this is only for comparison, guys. TCP IP not came from OSI or OSI is not came from only TCP. Okay. Look at here. Application layer, presentation layer, session layer. First three layers are as application layer and TCP IP. It contains only 4 layers. But it is same as a OSI model working. So that's why it is we are using OSI for understanding and creating and troubleshooting purpose. But TCP IP is more helpful because it's having a or no, it is not like that. We are all using TCP IP because standardized protocol and common for most of the protocols. TCP IP protocol suite compared to OSI application presentation session is become an application layer. So one layer, 3 duties. Next is a OSI layer, transport layer and transport layer only same, no changes in it. Network layer become internet layer. Data link layer and physical layer become network access layer. Network access layer. So if you got any question, you got a NIC, Ethernet or a, there. So which layer is a data link layer or physical layer? It is a network access layer in the TCP IP. Yes, this is troubleshooting of network using OSI model. Like you have a physical layer. So if you got any network related problem in layer wise, first you have to check the physical layer, means it's a physical connectivity. Next is IP address, network IP address. So is any IP address is changed or something improper configuration of IP address may give you not good result, right? Or IP address is changed. Okay, presentation layer, encryption related kind of stuff, compression related kind of stuff. Session layer, as I said already. Okay, session can be it will be maintained till the you got a complete transaction. Application layer, when what is the application layer part? Like your application is not working, your server is not working, you got a page not found, HTTP, SMTP kind of stuff. Yeah, whatever it is. So this is again, if possible, I will explain once more in a detail, but this is the application layer. So the next part I'm trying to go for a IP addresses after this one. that is also very big one. So we need to take at least another 1 hour. If it is finished, the networking part, main part of networking is completed. Any 1 or 2, that is okay, no problem. Okay. So guys, take a break, take a 10 minutes break, 10-15 minutes break, no problem.